Okay, so today we're going to cover section 5 of chapter 5, and we're going to learn how to use inequalities in a triangle. So our first theorem is Theorem 510. Again, the number is not important to us. And what this theorem states is if one side of a triangle is longer than another, then the angle opposite the longer side is larger than the angle opposite the shorter side. And I'm going to draw this in. Now, I know these numbers look weird. I don't know if they look weird in your picture also. This 10 that's over here, this is actually the length of side AC. It's 10. And this 1, 2 here, that's the length of side AB. So I'm not sure if your picture looks like that, but AC is 10 and AB is 12. And I'm going to talk about how we can figure out which angle is the biggest. It's either going to be A, B, or C. And we're going to look at the numbers that are across from it. This theorem says is that the angle, what we're going to do is we're going to see the angle. So angle B here, let me do this in a different color. So angle B, the side that's across from it. So see how this side doesn't touch angle B? So that's the side across from B. And then the side across from C is going to be the side that's 12. To figure out which angle is bigger, either angle C or angle B, I look at the length of the sides. So the side that's across from C is 12. And then the side that's across from B is 10. Which number is bigger, 10 or 12? 12. So the angle that's across from the 12 is the bigger angle. So you can either say as angle C is greater than B, if you wanted to write angle B, and then you could write it as less than C. More than likely, if this is the test question, part of it would be filled in, like you'd have a blank here. And you would fill in the correct inequality symbol. And that's what we're going to do later on in the examples. Theorem 511 reverses this. Now we're given the angle measures, and we have to figure out which side is longer. Same idea here. The bigger the angle, the bigger the side across from it. So we have angle 30 here, and I know the little degree symbol got shifted, but this is 30 degrees for this angle. And then there's 60 degrees for this angle. So we can see the side across from the 60 is going to be side AB. And then the side across from the 30 is side CB or BC. Which angle is larger, 30 or 60? The 60. So this tells me that side AB is going to be greater than side BC. So the bigger the angle, the bigger or the longer the side across from it. The next one actually has a name, and it's called the triangle inequality theorem. And this one states that the sum of the lengths of any two sides of a triangle is greater than the length of the third side. So let me fill in what goes on the other side of these inequalities. So what this is telling me that the side BC plus AC is going to be greater than the other side, which is AB. And then if I add AB plus AC, it would be greater than BC. And if I add AB plus BC, it will always be greater than AC. So let's say we give these numbers. So let's say this is a 6, an 8, and a 10. So let's say if we test it out. If I take BC, which is 8, and I add it to AC, which is 6, this sum should be bigger than side AB, which is 10. 8 plus 6 is 14, and you can see that it works every time. So all you do is take two sides at a time, add them. That sum should be bigger than the side that you didn't add. Okay, so they cannot be equal. The sum can't equal the other side. That would not form a triangle. So the first one, it wants us to name the largest angle in this picture, and this should be a 10 here. My 0 is hiding behind my triangle. Name the largest angle and the smallest angle. Which number is the biggest, the 6, the 8, or the 10? The 10. And the angle that's across from the 10 is going to be angle C. That's my largest angle. What's my smallest number here? Okay, it's side 6, so it would be angle B. Example 2. Okay, this time it wants us to name the shortest and the longest side. What do I have to do here first, you think? Can I tell that information just by what's given to me? Ashley, what do I have to do?
You have to add them and then subtract them from 180.
Beautiful. Because 46 may not be the smallest number. I need to find angle T first. So I'm going to add 46 plus 105. And I get 151. I'm going to subtract that from 180. And my missing angle is 29 degrees. Notice if I wouldn't have done that, I would have gotten this question wrong if I only used the 46 and the 105. So now, what is my longest side?
TI.
Okay, IT or TI? Good. What's the shortest side?
JI.
Okay, JI or IJ? Good. So that's the shortest. And then this one is the longest. All right. Next. All right, so we're going to fill in. Now, notice this time I wasn't given a picture. So I'm going to go ahead and draw a picture of a right triangle. I'm also going to label angle C as my right angle. It didn't matter where I put A and B. So now it wants me to compare angle C and angle A. Now, what do I know about angles A and B in relation to angle C? They're complements, right? So if I already know that I have one angle, which is angle C, that's 90, I know that what's left over for A and B is 90, because that's a rule that I learned, that the two acute angles of a right triangle are always complements. So angle C, is it bigger, smaller, or equal to angle A? It's bigger, right? Because it's opposite the hypotenuse, like Ethan said. So C is a 90-degree angle. So this side over here is the hypotenuse, which would be the bigger side. So I know that angle C is going to be bigger than angle A, because A and B together are going to equal 90. So, what do I know about the measure of angle C and A plus B?
They're equal to each other.
They're equal to each other. And now what about the relationship between AC and AB?
AB's bigger.
Good, because it's the hypotenuse. It's opposite the largest angle. So the next one, it states that the lengths of two sides of the triangle are 8 and 13. Then it's telling me then the length of the third side must be greater than something but less than something else. And these two numbers we're going to fill in. We're going to find those numbers by taking the two sides that are given to us. We are going to add them, and we're going to subtract them. So when I add this, I get 21. When I subtract it, it must be 5. So the length of the third side of the triangle has to be greater than 5, but less than 21. So, for example, it could be any number. So this third side could be a 6, it could be a 7, an 8, a 20, a 20.5. Any number that is going to be in between 5 and 21. And this X could represent the third side. So the way that you would find out what would be possible values for a third side is you take the two sides that are given, add and subtract them. And then the third side has to be a number in between both the sum and the difference. We're going to test this rule out on the next slide. This is giving us 3 numbers. We need to decide, will these 3 numbers form a triangle? So the easiest way to do it is just take the 2 smaller numbers, add them. If you get a number larger than the last number, then you say yes. If the sum is smaller than that third side, then you're going to put no. So 6 plus 8 is what? Since 14 is bigger than 10, you're going to say yes. Next one. 3 plus 4. Is 7 bigger than 8?
No.
So then you say no. These will not form a triangle. 2.5 plus 4.1. Is 6.6 greater than 5? Yes. Now, this one's mixed up. Remember, we want to add the two smaller sides. What's 4 plus 2?
6.
And like Dylan asked at the beginning, can it equal to it? No, it cannot. It has to be greater, that sum. And then now again, I'll take these last two. The 6 plus 5 is 11. Is 11 bigger than 6? Yes, it is. So the B and D could not form a triangle. Those would not be good sides for a triangle.